Okay, so day 4, last part of 2A is the central limit theorem. So far, everything we've done, the problems have said that the random sample was approximately normal. And we use the z-scores in the table A to solve it. But what happens if it doesn't say that? If it doesn't say it's approximately normal? Well, we have the central limit theorem for that. So we do a simple random sample from some size of population with a mean and a standard deviation. And the central limit theorem basically says if n is large enough, then it'll be approximately normal. Now I want you to put underneath the word approximately, no, not that. That little symbol, that little curly symbol from algebra. That means approximately. It's a tilde in Spanish. But the little tilde means approximately. Little tilde, whatever you want to call it. Little tilde. Okay? So, 2 new conditions. The normal conditions. The population distribution is approximately normal. So this is true no matter what the sample size is. So if they tell you that, we're good to go. Also, if the sample size is large. So if it doesn't tell us that the population is normal, the sampling distribution must be greater than 30. Okay? You have to have at least 30 people. So if it doesn't say it's normal, you need at least 30 participants. You can have less than 30, fewer than 30, as long as it tells you it's normal. So it's got to be one or the other. If it doesn't tell you everything works out normally, it's got to be greater than 30. All right. So, first off, we're going to find the mean and standard deviation. Step 1, which kind of we've been doing. Then you're going to check for normal conditions. Okay? If it's given, then we say yes. We put a check mark. So if it tells us it's normal, we go from there. If it's not given, we check greater than 30, and then go from there. So it's either going to be told to us, or we have to have more than 30 in our sample. And just like we've been doing, we're going to graph and shade, which is nothing new. Same thing we do it over and over again. And as you already have on there, we're going to find the probability using z-score and table A and figure out what the probability is. So, problem. Opening weekend for the top 1,799 movies of all time have a distribution that's strongly right skewed. So right there, this tells us that it's not normal. Okay? The population's not normal. So that's not given to us, which means we're going to have to check for at least 30 in our sample. So it has a mean of 26.2. That's an important piece of information. Standard deviation of 22.9. So we have to note these things that we go through. What is the probability? A random sample of 50. Right off the bat, we know we're going to be okay because it's over 30. We'll have an average opening weekend earning of less than 19 million. I'm going to write the word less here, bring it down to remind myself when we're looking at the chart how to graph that we're looking left. Steps. Now that you know that it's safe and nothing's going to get us, we're going to have 50 is going to be good. So step 1, and it's right here. Step 1, find the mean and standard deviation. Remember, we use that funky U. Okay. Remember that the sample mean is the same as the population mean. So looking up here, the mean is 26.2. Tells us that right there, 26.2. Now the standard deviation, remember, the standard deviation of the sample is our population standard deviation divided by the square root of how many we have in our sample, which we know is 50. Again, that's going to tell us we're going to be safe later on. That's step one right there. Boom, done. Step two, check normal conditions. Is it random? Question mark. Well, it says, up there somewhere, the word was random. Oh, there it is. Random sample. Boom. Random. Check. Okay, given. Random was given to us. Now, is it normal? Well, it does not tell us it's normal. In fact, it tells us it's right skewed. But if we check, n greater than 30, 50 is greater than 30, check. So we're good to go. It all worked out. Number 3 says draw a curve and shape. Simple enough. Now to do this, we need a z-score. So z is equal to the actual minus the mean divided by standard deviation. Well, we know the mean from number 1, 26.2. We know the standard deviation. Oh, no, we don't. Somebody, that would be me, forgot to calculate this. Nobody called me on it. So if I type in 22.9 divided by the square root of 50 in my handy-dandy calculator, I will get 3.24. That's my sample standard deviation, which is going to go down here in my formula. Now, all we need to find is what is the actual number that we're comparing to in our problem, and that's right here, 19 million. Okay? So if we type in 19 minus 26.2, remember, you either have to put this in parentheses in the calculator. Wow, look at that. And then divide by 3.24, or you type in 19 minus 26.2, enter, then type in divide by 3.24. If you don't do that, you'll end up dividing 26.2 by 3.24 and subtracting from 19. That will screw everything up. So be careful. In fact, let's just show that real quick, only on this one. You have two choices. You can type in parentheses 19 minus 26.2 parentheses, then divided by 3.24. And that will give us, I screwed it up anyway. I got the forward. Silly me. Let's try it again. 19 minus 26.2 parentheses divided by, and let's say I didn't forget it. It didn't register. That's what it was. It was the board. Negative 2.2 repeated. All right. Or I can type in 19 minus 26.2. Enter. Well, I can hit it. You know, what the heck? Let's try it again. Minus 26.2. Make my finger. Enter. Then divide by 3.24. Yes. And there we go. Same number. So you have two ways of doing it. Fine. You can also do the alpha y equals and go to that and then put in 19 minus 26.2 divided by 3.24. And there's our third way of doing it. Excellent. So we come back to this screen. That gives us negative 2.22. So we come to our tick graph and we go 1, 2, 3. We put negative 2.22 right there. And we just shade left because we were going less than. And it doesn't have to be a piece of art. And lastly, for number 4, we're going to take that negative 2.22 and we're going to look on our chart. Since we're looking left, we do not need to subtract anything. And that's going to give us 0.0132, or we can write 1.32%. Either one of those is fine. And that's our 4 steps to the problem. Now, we're going to more quickly, and with fewer errors, hopefully, I'm not going to do it on a calculator here, do the next one. So, your company has to contract, perform, blah, 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 blah. Okay, let's get to the good stuff. We have a mean and standard deviation given to us right there. We have a random sample of 70. That's important also. You're going to average 1.1 hours of work per unit. Will this be enough time? And exceeds. This is a very important word right here, exceeds. That means more than. It means to the right. Which remember that we're going to do a 1 minus something on that one. So let's get to it. Number 1, we do our funky U. X bar equals 1. Our standard deviation is the standard deviation of the population divided by the square root of how many we're doing. It says 70 units. So that's 70. That's like a 2. Starting again. 70. Closer. Now this time I'm going to remember to actually calculate it. When I do that, I get 0.18 hours. Right there. 0.18. Number 2, we're going to check normal conditions. Random. Question mark. Well, let's see. It says random. So, given, check mark. It does not tell us it's normal. So we need to check. And since we have 70, which is greater than 30, boom, we're good to go. We're already on to number 3. Let's do the z-score first this time, just for the heck of it. We're going to take our actual value, which says, what are we comparing to? Exceeding 1.1 hours. Minus our mean, which is from number 1. Divided by our standard deviation from number 1. And that's going to give us a simple calculation of 0.5 repeating. Okay? And your calculator should be 0.5 repeating. So, remember, on the chart, we need 2 spaces. So we're going to round that to 0.56. We're going to graph it, map it out. So we're going to go 0, 1, 2, 3, 0.56. Oh, just about halfway. We're not being really picky. And we're just doing that. Kind of shading from there. And we're shading to the right because it said exceeds 1.1 hours. So on this one, for number 4, we're going to say that 0.56 yields us 0.7123. But yes, we need to do 1 minus 0.7123 because we're shading to the right. And that gives us 0.2877. I will accept that answer, not on, or 28.77%. I'll accept either one of those. And last, but certainly not least, the same thing. So, number 1, let's go through it. It says we have a mean of 64.5 inches, standard deviation of 2.5 inches. Find the probability that the mean height of an SRS of 15 young women, 15, that is under 50, under 30. Should I be worried? Yes. Well, no, I should not, because, hello, it says it follows a normal distribution. So since it says it follows normal distribution, we're okay. We're also going to be comparing it to 66.5, and we're exceeding it, so we're going to the right. So number 1, we do our funky U, X bar equals 64.5. That's just given to us. Our standard deviation is the standard deviation of 2.5 divided by the square root of those 15 people. And when I calculate that out, I get 0.65. Always round properly, 0.65. That's all. Let's move on to number 2. Number 2 is easy. Random. You betcha. Given. Check. Normal. Given. Check. We don't have to do large numbers. In fact, we don't have enough for large numbers. But it told us it followed the normal distribution. So we're on to number 3 already. Look how fast that goes. Imagine how fast this quiz is going to go. Just like this. Bam. I mean, no time. Give it to you right now, you base it. So, number 3, we're going to do a z-score. Z-score is our actual score we're comparing it to, which was 66.5. That was right here. Minus 64.5 divided by our standard deviation of the population, which was 0.65. And that gives us 3.08. Now we're going to map that out simply. And we're going to say 0, 1, 2, 3. Where's 3.08? Out there. And since it said exceeds, we're just going to make a little line and shade that little part right there. Tiny, tiny amount. You can see it on the map. Tiny. So, number 4, we're going to look up 3.08 on the chart. I didn't screw up. That was on purpose. Okay? And when we do, look how tiny this is going to be. Well, that's going to be huge, but it's going to be 0.9990. But it's not really that, is it? We do 1 minus 0.9990, and that gives us 0.001, or 0.1%. Not 1%, 0.1%. And that is our likelihood of that. Okay? Now, the homework says 9 through 12. No. No. 9 and 10.